Hello everyone and welcome back at another video for the Utrecht University course Introduction to Bioinformatics. We're at the point that we have mapped our samples back to our metagenome assembly. We have sorted the BAM files that are a result of this process, and now we're ready to start with the binning process. And this is the first part in today's practical where we really differentiate from the genomics practical of the day before. So remember, in topic 1 you've also used BWA to map DNA reads back to an assembly. You've also sorted these BAM files, but today we're now using these BAM files to differentiate multiple genomes within that assembly instead of variant calling like we did yesterday. So real metagenomics happening here. Make sure that you've made the exercises and that you know how everything works, and then come back to this video to check if you did well. So let's see, we're using metabat2 actually, so let's correct that right now. Click. There we go. And metabat2 uses multiple binning signals, as Bas explained in his lecture, to differentiate what contigs in the metagenome assembly, or what scaffolds in fact, belong to one assembly and what belong to the other. One of these binning signals is depth, so a sequencing depth, and this is what we can determine with the BAM files we just made. There's actually a lot of information in those BAM files, so we want to take only the information that we really need and put that in some kind of a easy to read small table. And that's exactly what this script does. This is a script that comes installed with metabat2, and it's the JGI summarized BAM contig depth script. So let's see how it works. Like you see, I have the help page open for the JGI summarized contig depths. If you read the usage line, JGI options sorted BAM number 1 and then optional sorted BAM number 2 ... indicating we can put as many BAM files in here as we would like. So in the assignment described above, you can see that we need this one file coming out that describes the depth of all contigs in all samples, and that's exactly what the first option here does. Can I select this? Yes. Output depth. So that's an option, so we'll type minus output depth. Quite often when you type an option, you interconnect all words, but new words start with a capital to make them a bit easier to read. And this option needs an argument. So I'm going to call this data/depth matrix.texts.top. I like .top better. I'll explain later on. So that's the option and the argument that comes with the option, and then we have data sorted. Come on. Sorted slash a whole lot of BAM files, and I could now put these in one by one. Take away my mouse, but that's not very convenient, so what I'll do is I'll use a wildcard like this. So this will take every file in the sorted directory that ends with sorted.bam. If you're not sure if your wildcard works like you would like it, we can do this. We do ls data sorted /star.sorted.bam, and the files that pop up are all the BAM files that we would like. So let's say that we were perhaps a bit more sloppy and we made our sorted BAM files in the directory where also our unsorted BAM files are. And we would not include this part, but just the star like this. You would actually put in each BAM file twice, the sorted version and the unsorted version. So the program will crash on this, so you will make a mistake, but let's imagine it doesn't, then you actually make a mistake without knowing. Moving on, running this script, console return. I think this is relatively quick. Yeah, so while this is calculating, I'll pause the video. Yep, and we're back. The script just finished calculating. It opened each of these BOM files. There were a whole bunch of reads in there, and it tells you some statistics. It also tells you that it created a depth matrix file that I called data/depthmatrix.tab. And then it's done. So it is always good practice to open the file, to have a peek in the file that we just created, to make sure that it looks like we would expect. So this may look like a mess, but again, remember this is a really big table. And this table in fact is so long that it doesn't fit on the screen. So this actually is one line. Perhaps if I make it smaller, it will just fit. No. Make it big for you. There you go. So this here is one line. It has the name of the config, the config length, total average depth over here, and then the depth in this sample, so this is the name of the BOM file, it's over here, and then the variance in that depth, which is over here, which actually is a binning signal on its own. So you may notice that these numbers are very low, so this is 0.4, then the next depth is 0.6, the next depth is 0.3, and if you're very observant, you may realize that if the average depth is 0.3, if it's just lower than 1, how can you then ever assemble it? That's a valid file. So remember, I subsetted the read files that I gave you. So actually in the original assembly, in the original sample, these numbers would have been 10 times as high. Okay, so then there's this exercise below. First there's this. So one of the things I ask you here to do, and that's something that you normally never do, is to remove some of the data that you've created. We're now at 50 people on one server using one really big CPU and also one big hard drive. And we want to be a bit social to each other and also leave enough space for the rest of the course. So what we can do is remove part of our data that's arrived. So we won't remove the original reads. Removing original data is something you never do. But something you can do is remove the mapped folder. Since in there you have the unsorted BOM files, you can remove them safely, so let's do that. And what you can do is to remove the sorted folder now. So that's again something that I would normally absolutely not recommend, but now you can. Please just double, triple check that this looks okay. So you have, oops, go away. You have these six samples in there, and the numbers look a bit like this. And only then you can remove them safely. Thereby we save a lot of disk space, we save a lot of disk space for the rest of the course. Just put this back. Okay, so then comes this whole other part of the course. I'm gonna make a separate video for that. So I'll see you in the next video.